Welcome, everyone. I'm James Shore, and this is the Art of Agile Development Book Club. Today, we're discussing refactoring, an essential technique for maintaining and improving your code. And I'm very happy to have Martin Fowler joining us as our special guest for this session. Martin is the author of Refactoring, Improving the Design of Existing Code, which is the seminal book about refactoring and is out now in a second edition, as well as many other books and articles about software development. He is chief scientist for ThoughtWorks and describes himself as essentially a loudmouth pundit on the topic of software and enterprise application development. But despite his humility, his influence on the industry cannot be understated. You can find his writing at martinfowler.com. Martin, welcome.
Oh, thank you for having me.
Yeah,
It's been quite the journey watching your second edition evolve.
Thank you.
It was good fun taking part in it.
Yeah, I was really happy to have you participate in the review and write the foreword as well.
Yeah, I was very proud to write the foreword. I don't write forwards lightly, and so it's always quite fun to put one down.
Thank you. To get us started, I am going to read an excerpt from The Art of Agile Development. As a reminder, the second edition is out with that forward by Martin. It's in both ebook and print editions. You can get it from Amazon by visiting jamesshore.com/s/buyaoad2. And you can find excerpts and bonus material by visiting jamesshore.com/s/aoad2. Refactoring. We improve the design of existing code. Code rots. That's what everyone says. Entropy is inevitable, and chaos eventually turns your beautifully imagined, well-designed code into a big mess of spaghetti. I used to think that too, before I learned to refactor. Now I have a 10-year-old production code base that's better today than it was when I first created it. I'd hate to go back. Every year, it's so much better than it was the year before. Refactoring makes this possible. It's the process of changing the design of your code without changing its behavior. What it does stays the same, but how it does it changes. Despite popular misuse of the term, refactoring isn't rewriting, nor is it any arbitrary change. Refactoring is a careful, step-by-step approach to incrementally improving the design of your code. Refactorings are also reversible. There's no one right answer, so sometimes you'll refactor in one direction and sometimes you'll refactor in the other. Just as you can change the expression x squared minus 1 to x plus 1 times x minus 1 and back, you can change the design of your code. And when you can do that, you can keep entropy at bay. Let's get started with our first discussion prompt. So refactoring often starts with a design change and then applying multiple refactorings to reach a goal. And this prompt is for everybody, but I'm going to start out with Martin. What are some of the typical design changes that you see most frequently when you're refactoring, Martin?
Well, I should preface what I'm about to say with a big caveat, which is I don't do any real work anymore. So I don't sit and help clients with gnarly code bases, and haven't for quite a long time, because most of my work now is in the writing side. So the programming that I do is mostly my own code base and my tool chain that supports my website, which is a small project. It's not big. It's a low 10,000 lines of code kind of thing. So it's not massive, but it's not tiny. It is old because it's now 20 odd years old. But it's all written by me, so it's beautifully constructed, of course.
Of course, yeah.
But as a result, that will mean that I won't necessarily give the same answers that somebody who's working on a more gnarly code base with a team of people is going to have. Yeah. I would say I never really tried to classify it, but I would say the most common changes I would make are when often I want to override or add some new feature that allows me a bit of flexibility that I don't have at the moment, but the code isn't in the right shape to do that. I mean, the simplest case would be a method that does, the change I need to make is a little bit of this method and a little bit of that method. Mm-hmm. And so I need to refactor it to make it just so that it's a single function, and then I can more easily put it into the flow that I want. Or another common change is where I've got a bit of data that's in the wrong place. So I've got a piece of data over here, and I realize I can't get to it easily from somewhere else where I need it. And I don't want to put a direct link to the place, and that would be a refactoring itself. But typically I want to move that data to a place that's a more logical place now that it needs to be shared more widely than it was when I originally put things around. So those strike me as perhaps the most common kinds of things that I want to do that tend to lead me to a refactoring. And those tend to be what I call preparatory refactorings, where there's a change that I want to make and this code is not in the best place for that new change. And so I make it. It's the classic Kent Beck, make the change easy, then make the easy change routine. Right. And that I would say is the most common design change that I do like that. But it's also true to say that I often, in the process of doing that, will look at something and say, that's not right. And then I will opportunistically make a change as I go through. It's amazing how much room there is still to improve a 20-year-old code base that I think is perfect.
Yeah. Love to hear from those of you in the audience. What kind of design changes do you see that you either refactor or would like to refactor? One of the most common refactorings I see was actually one that was brought up in the Discord. And for those of you who aren't familiar with the Discord, we do have a Discord discussion every week about the book club topic. You can find that at jamesshore.com/s/AOAD2 Discord. And one that I see fairly often is when you have a really big convoluted class with a whole bunch of stuff, or method with a whole bunch of stuff going on, and then refactoring that into bits and pieces, and then going from there. What would you do in that situation, Martin?
Well, it sounded like very much like what Sarah said she did in her example. I mean, there's nothing nicer to do than take a really gnarly piece of code and show how it can be refactored cleanly. The hardest part of that is making sure you got good test coverage. I mean, once you got the test coverage in place and you can be confident with it, then the refactoring part of it can be incredibly pleasant. Because it's often very with a gnarly control flow thing. And the example she gave was, some god awful big switch statement that has lots of stuff. And that kind of thing is quite nice because you just take the legs of the switch. I love decomposing switch statements like that because it's just fairly straightforward. You just extract the legs of the switch, put them into their own methods, move those methods into different classes. It's just such an appealing process. But the hard part, as I say, is getting the tests right. And one of my favorite things to do to help with that is to make deliberate breaking changes to the code, reverse a conditional, comment a line out, and see if a test fails. And then if the test catch it, then you're okay. And if the test fails, you've got a new test to add. And you can and that's basically mutation testing done manually. And I find that can be a very effective way to help you with that kind of thing. And I even do that on my own stuff. If I'm going, am I sure my tests are okay for this? And throwing in a little bit of mutation is a really good way to check your confidence level for that.
What about the speed of the test? How does that play into this? You talked about it being really comfortable, and I certainly agree with that. I love refactoring. When I've got an idea and I've got the time to do refactoring, I've got a good suite of tests. It's so easy to just do a little piece and a little piece and a little piece. But how does the speed of the test play into that? What if your tests take 30 seconds to run, for example?
Well, I'm relatively tolerant of test times of 30 seconds because I remember when you're going to run the test, that's an overnight job. That was fairly standard when I was started in this game. So 30-second tests, wow, those are fast. And maybe I've got overused to that. But they definitely, when it starts leaching into the minutes, then you begin to say, okay, I've got to do something to slow down. So you either look at speeding your tests up or you choose a subset of tests that you think are the ones that are going to cover you more clearly. Or maybe you have to create a subset of tests. I mean, that's where you've got overly broad tests and you need more narrow ones that will cover your ground. I mean, if you're going to do a reasonable refactoring operation, you're going to be slowed down by excessively slow tests. So it's worth investing a bit of time to speed those tests up. But I probably am more tolerant than many of the kids today when it comes to test speeds because I mean, hey, getting the program to compile in under 30 seconds was a non-event, basically, when I started. So I'm naturally a bit more used to it.
Yeah, yeah. I have to admit, I get frustrated easily. I'm an impatient person, so I start getting frustrated when the tests take more than about 10 seconds. And really, what I want is for them to be under 5 seconds. But let's switch gears for a moment. Let's talk about the big picture of refactoring. What about so refactoring, of course, is part of the overall software development process. And one of the things that I've heard people say is that we don't have permission to refactor. Our product owner doesn't want us to refactor or thinks it's a waste of time. What would you say to those folks?
Well, what I've always said is that's not something you need to tell them about. I mean, they don't. You don't get permission. You don't get them saying, should I use the S key, or should I? How do I put spaces around my operators or not? These are what they pay you to make that kind of decision, and they pay you to make the decision about whether you should be refactoring or not. Frankly, that's what a good developer's judgment should get into. So that's the broad. So, and that also reinforces the fact that for me, refactoring is something you do a little bit of every day. Mm-hmm. So every time I'm adding a new feature to my code, I'm doing a bit of refactoring as part of the process. I mean, unless astonishingly the code is perfectly factored for the change I'm going to make, which hardly ever happens, even on my wonderful code. So you're always going to be doing a little bit. And it's those little bits that count over time. Mm-hmm. But fundamentally, that's the key to it. I think it's making the refactoring just be part of your everyday work. So every time you touch the code base, you do a little bit of refactoring to improve things.
Yeah. I wonder if, because I do hear this a lot, I don't have permission to refactor. What do I tell my product owner? And I wonder how much of it is because people treat refactoring as not something you do constantly, but rather something you only do as in a big chunk. Or I often see people say, I'm refactoring. Really what they're doing is they're throwing away the old thing and they're writing a new thing.
Right.
Which I guess you could call that the substitute algorithm refactoring, really large scale.
No, because the whole point of refactoring is small steps, right? You take the smallest possible step you can think of. So, if you're throwing away the program and rewriting it does not count as a refactoring, even if you preserve observable behavior.
All right, everybody. I want you to screenshot that right there, put it with a nice meme font, and paste it on Twitter. Rewriting doesn't count as refactoring, Martin Fowler. As a reminder, this is a call-in show. Love to hear from you. Just raise your hand if you have something that you'd like to add to this subject. Are you in a situation where you don't feel comfortable refactoring? You feel like you don't have permission to refactor? And Alistair, welcome to the show.
Thanks. Well, I'm not in that situation, James. But what I've found for myself in the past to change the mental model of programmers who will raise that exception and have raised that with me. And they raise the same issue with testing as well. I like to say that coding, testing, and refactoring is just coding. That is programming. It's not distinct activities. That is just programming. Like there's no distinction. So when you ask me not to test or refactor, you're essentially saying don't program, which doesn't make any sense.
And design.
I feel like that's my mental model that helps people shift around their attitude.
Yeah. Thank you very much for that comment. I appreciate it.
Definitely.
So if refactoring is a series of small steps, then how do you get to this point of doing small steps? I do see a lot of people who are really struggling with this. We can only refactoring big pieces. What would you say to them about how to get into small steps, Martin?
I mean, it comes down to practice, right? I mean, and that's partly why I wrote a book full of refactorings, right? To try and give some people a sense of how small your steps can be. You just have to get used to the fact that you want to make the smallest possible change you can, commit. Smallest possible change, commit. Smallest possible change, commit. And over time, you get used to trying to spot how you can make your changes smaller. And get used to such things as you make a kind of big change and you're still on red and you're feeling a bit wobbly and you go, I see. If I did it a different way, I wouldn't be on red so long. So you just revert your entire change that you've made for the last however many minutes. Well, I'll usually stash it, right? Throw it in stash, go back to the last thing, and then move forwards in on green more often. And that kind of practice helps as well. Just reflecting to say, how could I do this slightly big and nervy change? How could I break it down and do it more in smaller steps? Yeah. And get used to doing that. Reflecting, and of course, that helps having a mentor who can help prod you in this direction. But it really is the key is, how do I keep my steps small? And it's the same even when adding new features. You always want to say, how can I make the tiniest little change I can? Because as soon as you're back on green, you can then put the refactoring hat on if you need to. But you can only put that refactoring hat on once you've got back to green.
Yeah. This strikes me as if any of you, the audience, have a refactoring puzzle that you've struggled with in the past, I think that would be this is a great opportunity to ask Martin his perspective on that. I would certainly agree with you on that small steps. I know that, having practiced and practiced and practiced, I'm always finding ways of making the steps smaller in refactoring. One of the things I'll be doing a lot, sort of what you mentioned at the beginning, Martin, is I'll be moving variables around so that I can pass something from here to there. I have, of course, a code base that runs my website, as it's sort of a rite of passage, isn't it, to write your own website. And when I first did it, I was under a long time pressure. So I put some globals in, and I'm still to this day refactoring out those globals and replacing them. And it's really just a matter of getting the data in the right spot. And I'm to the point where I will move it up. I will move a variable up one lexical block and then run the tests, and then up one more lexical block, and then to one caller, and then run the tests. And that level of fine-grained changes. Let's, in the Discord, there was a big conversation about whether or not refactoring is realistic. That technically speaking, everything can lead to a change in behavior. What's your take on that, Mark?
Well, this is why in the definition of refactoring, I threw in the weasel word observable. Mm-hmm. Right? Because strictly, if you say refactoring can't change anything about the existing program, and you could never make a refactoring, because even a completely behavioral changing thing will change its runtime characteristics typically in some way that you could detect, maybe statistically only, but you're never going to be able to change anything. I mean, one of the examples, I didn't actually get through the whole Discord thread because I didn't realize it had blown up yesterday afternoon, was changing the name of a private method that people shouldn't be able to reach, but may be able to reach through reflection. So is that then a change that you can't make because somebody might have used that? And again, you have to make your decision, and I think that came in, I think you may have said it, you've got to make your own decision about what considers to be observable behavior. Some people say, well, you can't change anything that changes an API. But that isn't true. You got to be wary about changing a published API, one that reaches outside of your code base. But I change internal APIs all the time, and in fact, with modern renaming tools, that's actually become a trivial change, right? I mean, you just go rename method, and it just does it. So you're always looking at this sense of external behavior and deciding where your bounds are as to what is a sufficiently noticeable change to be observable. Mm-hmm. But that was why I say I, but I think it was probably we. I probably discussed it with Kent and Ron and folks at the time. Came up with this term observable because if you don't see it, then I think and a good example of this is if you in the course of refactoring notice a bug and fix it, and that bug was never noticed by the outside world. Does that count as a refactoring? Well, you could argue that it doesn't, right? Because you changed the behavior because the bug's no longer there. But if nobody ever saw it, then I think you're okay because then it wasn't observable, kind of by definition. Mm-hmm. But your team has to decide what counts as observable. And one project, one situation is not going to have the same bounds on observability that others will do.
Alistair has another comment on that. Alistair, welcome back.
Thank you, James. Like in my head, when I was listening to you folks talk about it, I think people are, they don't want to introduce risk, I guess, to making the change. That's really, it's really what's going on. It's like, how much risk can I absorb? And so, back in the day when I was a wee programmer, myself, I used to, my mental model was the safest change is the sort of smallest delta to the code base. Like that's how I used to think. And I think a lot of people still think that. Whereas like now that I'm more familiar with testing and refactoring and evolutionary design, I realize that making those little sort of smallest possible changes in terms of the delta of characters is actually not a great way to evolve the code base. And I'm actually doing more risk by making those little piecemeal things. And as much as refactoring does introduce risk overall, I think introduces risk. I think overall it reduces risk.
So by making the smallest little change, what you mean is you'd avoid making changes. You'd only do what was necessary to add features.
Well, rather than, thinking that I want to separate off this behavior by extracting classes, I might introduce I'll be really silly. I'll introduce a global variable, make an if statement somewhere where I want to make the change, way down here where I see the symptom, and I'll just kind of microsurgery on that symptom rather than restructuring my code.
Yeah. I certainly see that kind of behavior a lot from programmers. Is my job is to add features, and I'm going to do that by making the least change possible, but not necessarily the least disruptive change possible.
Right, and then my design slowly corrodes, right?
Yeah. Thank you. Thanks for that comment, Alistair. Franz, welcome.
Thank you. Actually, I wanted to respond first off to what I think Alistair was saying, at least what I heard, was it seems to me like there's an important distinction to be made between how big your overall net change is, your aggregate changes, and how big your individual steps are. And I think that when we talk about making small changes, we're talking about doing potentially large changes, but in small steps, which to me seems like an important distinction there. But one other thing I wanted to say in response to what you and Martin were talking about was, so we talk about, classic TDDs being red, green, refactor. And if you read Slikes, I think the strongest example of this is some of the stuff that Kent Beck says in his book about TDD. There's this classic pattern, which I think nowadays tends to get called fake it till you make it, where, let's say you're TDDing an addition function. And so your first test says, that 2 + 3 = 5. And so your first implementation, the thing that gets you out of red, says return 5. And then we say, okay, now, then you take your next step and, you say, okay, now what it really is, return X + Y. And we call that a refactoring. But the more I think about it, the more I think that's not actually a refactoring, although it depends on context. This goes back to your saying, what counts as observable. And I think in that case, we're saying observable means it won't make the test change. But I think that's really too narrow of a definition there. That really, it's hard to argue that going from return 5 to return X + Y is not an observable change, which makes me, think about how the refactor step of TDD, of classic TDD, it's a little wishy to call that refactoring. To me, it seems more like generalization.
So Martin's waving his hands
moving from
crazy.
Returning 5 to 2 + 3 is not a refactoring, and I don't think Kent would say that.
Oh, okay.
That is absolutely not a refactoring. That's a change in behavior.
All right. But we still say, when you say red, green, refactor, that's the refactor phase.
No.
That's the language we usually use.
No, that isn't. That is not what the refactor step is about. The refactor step is about you've put some... maybe I've kludged together some stuff with a for loop over here, and maybe grabbed the using this global variable over there, and then I say no, it does not work. I need to do something better with it, and I'm then not just not changing the tests, but not changing the behavior beyond that.
Okay,
I mean,
so
you're right. I mean, the 2 + 3 to the 5 to 2 + 3 example, that's absolutely not a refactoring.
Okay, so you would say that's part of the green phase rather than part of the refactor phase.
That's adding behavior.
Okay, but I guess what I'm a kind of pedantic guy, so I'm maybe going down too deep into this rat hole, but it seems like if we're going to be pedantic about that classic TDD has those 3 phases and all changes fit into one of those 3 phases, then it seems like what you're saying is that change fits in the green phase.
That change is to do that change, what you'd want to do in kind of the by the book form is you'd write another test that would be 2 plus 7, and then change the code so that it satisfies that second test. And on that second time, because you want to avoid duplication, you'll actually put the addition in rather than returning I suppose you could be silly and go on for a while putting, if these are the inputs, return this hard-coded output, but you'll quickly go to the addition sign unless you're trying to be strange about it. But it's a new behavior. And of course, you can then elide that to some degree by saying, well, I'm going to put the plus in right away without the additional test. And that's fine too. But it's still a change in behavior. You're allowed to add new behavior without going red in the process if you're comfortable with the way your tests are lined up. Yeah. All right. Well, I see lots of other hands, so I'll let you go. I still think we're being weaselly here. We're not committing to what if we want to be dogmatic about that it's those 3 phases and those 3 only, which seems to me like what Robert Martin says. Then you got to assign that change to one of those phases. You won't get dogmatism out of me, I'm afraid. Yeah. I'm not a dogmatic kind of guy.
Thanks very much for your comments.
I don't tend to have much patience with dogmatists.
Thanks very much for your comments, friends. I think the area in which this sort of falls apart is where I think a lot of software development techniques fall apart is when you treat it as something where you turn off your brain and just follow the rules. I don't know if it showed up on the video there, but there was a big thumbs up from Martin on that one. Harold has a comment. Harold, welcome to the show.
Thank you. Really glad to be able to hear Martin Fowler. This is amazing. The question I have, and this is a question, so not a comment, but the question that was raised was about refactoring being a design. You have a design intent. And I really have found the read by refactoring from Arlo Belshi to be a useful process, which doesn't seem exactly like I have any clue about making a design improvement. So I'm wondering if you'd comment on that.
Yeah, I mean, refactoring comes in different forms. And certainly there are times when I refactored just because this kind of looks ugly and I don't really have a design intent. I'm just cleaning it up. There was a metaphor Ralph Johnson used once, particularly working on some more kludgy code, where he says, the first moves you want to make, it's like cleaning the dirt off the window because you can't see where you want to go until you've got rid of the dirt. And often early refactorings are kind of like that. Let's get these names straight. The importance of getting your name straight is really crucial here because a misleading name can really throw you off. I think where this gets more interestingly problematic is where you've got people with different coding styles, where what they're familiar with and what they're comfortable with is different. And of course, when you're in a team, you've got to come up with a team coding style. So that's always going to cause a certain degree of friction. But often when I'm looking at some code, the first things I'll do will just be to make it a little bit more comfortable for me to read and understand so that I can see where things go. And then you can refactor in that kind of direction later on. But yeah, just cleaning up is an important part of the refactoring picture.
Yeah. Thanks very much for your comment, Harold. And just in case those of you in the audience haven't heard of it, Arlo Belshi has this idea of read by refactoring, which is learn the code by giving things names and extracting methods and using the automated tools to make sure that those are safe, even if there aren't tests. It's a really neat idea, and it comes from his work in doing a lot of work with legacy code. So it's particularly valuable when you're in a legacy code situation. Did you want to add anything else to that, Martin?
No, I mean, other than also recommending this thing, it's interesting. We were just chatting before we started the call. That was actually what I was doing before we came on the call. Somebody had written some code example in a style of JavaScript that I'm not super keen on. And I changed it to the style I'm more comfortable with to help understand what he was trying to do. And some of that is renaming. Some of it was just moving things around. But it helped me understand the code he was looking at. Now, in a real project situation, then you get the whole question of, well, if that's what the team is used to, this style that I'm unfamiliar with, well, I've got to kind of learn how to work with that style. But sometimes there's an argument for saying, well, go and refactor it into your own form in your own area, understand what's going on, and then basically throw away your own changes because you've just used it for your own understanding. And there's something to be said for that, because refactoring, it's like how one of the things that we did right from early on at C3 that I really liked was using refactoring as part of your code review process. So these days we have this, and don't get me started on pull request code review workflows, but this idea that you hand your code over, they'll review it and send you comments back. What we'd prefer to do is say, we need to review that change that you just committed to main, right? Because we were using continuous integration, but we need to go for a review of that. And we'd sit down and pair where I would refactor with them the change that they'd made, basically, and refactor that change. And we would discuss how that refactoring worked, whether it was better or not, and why it fitted better into the team's coding style, or whether we should consider modifying the team's coding style. So the code review would essentially be a pairing refactoring session of a change that was made. And that's a very powerful form of code review, because the first few steps are the cleaning the windows style steps, right? Now I see what you're trying to do. I can see this change. And you end up with a much richer code review as a result, because you're able to go further than you would do if you were just looking at it on your terminal and you weren't making those changes. So there's a lot to be said for those kinds of processes that are easily lost if you're not into the habit of refactoring as regularly.
I really love that technique. This is the first time I've heard that, because the modern sort of open source inspired pull request format, I don't think actually translates very well to an environment where people are working full time. And yet it's because open source is so popular and Linux is so popular, I think it's sort of taken over the world. But I love this idea of, let's do if we must use pull requests, if we can't use pairing or mobbing, and we have to do code review. I love this idea of doing it with code review or doing it with refactoring.
And Alistair mentioned in the chat, yes, I actually called it comprehension refactoring in the book.
Michael has a comment. Michael, welcome to the show.
Hi. Hey, Martin, I'm a fan of your book, and I've been trying to get it going with my team, in a large organization. And I noticed you organized it where the front flap, I think it's the front flap, has kind of a code smell catalog. The back flap has refactoring catalog. And it seems like there's a thought process there where an engineer on the team could go to the code smells, find a problem that they're working through, and then refer to the pattern catalog to start a discussion with the team about how to refactor the code and how to plan out and coordinate that work. And if you had a copy of the book, Candy, or otherwise could walk us through that kind of thought process, I thought it'd be really interesting to hear about that.
Yeah, the smells are on the back flap, and the list of refactoring is on the front flap. But that's basically the idea. The technique I heard somebody say that they found they was really like would be to kind of pick a bad smell of the week. So that pick one, that's kind of start the week, pick one of the smells and say, this is the smell we're going to focus on this week. And then ask people during the course of the week to really concentrate on looking for that smell in the code base. And then when they see the smell, they got two choices. See the smell. That was a really bad mixed metaphor. When they see the smell, they have two choices. If they can easily see how to fix it themselves, go ahead and fix it. If they can't see how to fix it, go to a more experienced developer, the lead or whatever, and say, help me fix this. And then you'd fix it together. If you're using mobbing, this would be a perfect environment for a mob session, right? I'd see this smell, I don't know how to fix it. And maybe the lead would say, actually, this is so interesting, let's make a mob session for it. Because what you're doing is you're educating the whole team. The great thing about smells is that they're easy to spot. They may not always show an underlying problem, but they're easy to kind of get the nose going. Then once you've got the nose going, then the problem is, okay, what do you do about them? But at least you've got an alert system. If I've got a bunch of developers who aren't the greatest developers, but have got their noses are sensitive, I know that they can come to the more experienced people in the team and say, okay, how do we fix this? And then that allows the team to raise its knowledge level generally because they'll see how the fixes work. That's what, I mean, Kent made two great contributions to the refactoring book. The first was teaching me refactoring in the first place in a hotel room in a courtyard in Detroit, where I saw how he took so tiny, tiny steps. And I'd always been keen on cleaning up my code, but I'd never done it in those tiny steps. And it just blew my mind to watch him do that. And then the second thing was when he was living in Switzerland and he came up with this idea of code smells. And we drank whiskey and came up with crazy names for code smells in one evening in his flat in Zurich. But the code smells idea is brilliant because it just so allows you to find a way into the refactorings.
I have to say, when I first came across the refactoring book, it was incredibly influential for me in terms of how I approach design. And it was the code smells that really resonated. As you say, it's fairly easy to find them. Thank you for your comments, Michael, by the way. It's fairly easy to find them. And then the question is, what do you do about it? And what I discovered was that in reading the book, it wasn't so much about memorizing the individual patterns in the book, but rather what I tried to do was absorb the ideas underneath the patterns. And what I then really pay attention to the code smells and then kind of ignore the rest of the book. Sorry, Martin, and try to figure my way through the rest of them. So do you have any rules of thumbs or guidance for us about how you can refactor without necessarily referring to the pattern catalog? Like what rules of how would you approach a refactoring if you weren't just remembering a refactoring?
Well, I mean, it's how do I make the smallest possible change that will keep me on green? That's always how I think about it. How do I get the slightest possible change? And I mean, that's even true with the refactorings in the book. I mean, if you can see a way to get to green faster than I suggested, do it. And then, if you do break something by accident, always revert and go forward again in smaller steps. It's almost, I mean, very, very rarely it can be worth, when your code goes red, saying, oh, I know what the fix is and fix it. Almost always, it's better to just, now revert the last refactoring, go back to my next stable state, move forwards again, smaller steps this time. And I do that, and I have no idea what caused the problem first time round. I never debugged it. I don't care. I'd much rather just move forwards on stable steps.
I think that
key.
I think
those small steps.
I think that lesson is actually one of the hardest ones to learn. I know that it took me a long time to get to the point where I was comfortable throwing away the code and also checking in frequently enough to be able to just do a git revert or an undo in my editor. But it's so tempting when you're when you're trying to solve a problem, you see it didn't work, and you're like, well, I just need to make this change, and then I just need to make this change. I did that in a demonstration of refactoring once for about half an hour, and then I was like, okay, I screwed up, and we got to undo this, and then the undo didn't work. And if I just stopped right at the beginning, it would have been better. We've got a comment from Andy. Andy, welcome.
Yeah, so it's really a question. So TDD testing and refactoring are kind of fairly easy to learn in isolation, but how do you teach like an inexperienced team the tactics to approach a legacy code base that doesn't have much test coverage and that's kind of gnarly and untestable? So that's kind of riffing on what Michael said, but I think there's some different angles there to think about with an inexperienced team and a gnarly code base.
Well, you have to realize they do go together, right? And the problem, I mean, in some ideal world, you would get the code base completely under test, and then you could start refactoring it. But in reality, you're not going to be able to get it under test without some refactoring to create the seams that allow you to get the tests in place. So you're going to have to do a little bit of both. And it's about learning how to set up simple test fixtures. It's about learning how to draw in some of the seams. This is where you have to go back to another old classic book, Michael Feathers's Working Effectively with Legacy Code book, to give you some guidance about how to do that kind of breaking up. And And you have to accept the fact that things are always going to be slower and more awkward. You are helped these days if you're in a language with refactoring tools, because they can make a lot of steps much more straightforward. I mean, renaming can be a very fraught exercise without refactoring tools, but in a strongly typed language, in a tool like IntelliJ, it's a very straightforward process. So, I mean, it's always going to depend on those there's lots of different factors that are going to complicate a particular step, but you can't do them separately. You're going to have to do a bit of testing, a bit of refactoring, gradually over time, work the code into a better state, and it's going to take a while. I mean, it is. I mean, if you build a legacy code base over a period of time, it's gnarly. It's going to take a long time to ungnarl it. There's no getting around that, I'm afraid. That's just the way it goes.
Yeah.
But do little bits, a little bit every day, a little bit more every week. Over time, you can actually have quite a big impact. But it's going to take months, if not years, before you really see, oh, things are much better. But you've just got to do a little bit of it all the time.
And if you focus your efforts on the parts of the system that you're actually working on, rather than just any part of the system, the parts you're working on most frequently actually will get better fairly quickly. Yeah, it'll be years or maybe infinity before the whole code base is perfect. But the parts you work on most frequently can get really clean. I think we could spend a whole session on legacy code alone, but unfortunately we are out of time. Thank you for your comments, Andy. Thank you for your comments, everyone. I think there's a lot of interest and excitement about this topic, so please continue the discussion in the Discord. That is jamesshore.com/s/AOAD2 Discord. Next week, we're going to be discussing task planning, including topics such as iterations, Kanban, estimating, and capacity. So be sure to mark your calendar for the following week, for that week. And then the following week, April 29th, Kent Beck will be our special guest for a discussion of evolutionary design, which I am really looking forward to. So keep an eye on jamesshore.com/s/AOAD2 book club for more information. And do be sure to join the Discord for the discussion of each week's topic, which I'll kick off on Monday. And although, of course, you're welcome to discuss anything Agile related on the Discord all week long. Martin, thank you so much for joining us. Reminder, everybody, you can find Martin's writings at martinfowler.com. Once again, Martin, thank you.
Thank you. Glad to be on.
Yeah, this was great fun. I wish we could keep going, but that is all our time. Thanks very much, everybody, and I will see you next time.